ND Strike program, which is, here's the Strike rocket. This is our last configuration that we've successfully flown. It's pictured here in about 11-foot configuration last May at our very first test launch. So first of all, with ND Strike, what is ND Strike? It's a North Dakota Student Rocket Initiative project. Right up here. There's two components to this program. The first component being that as students directed by actually Dr. Young here at the university and other such advisors, we construct this rocket, or the VLR, the Very Large Rocket. This rocket is to fly student-made payloads up to an achieved altitude and thus make it into competition. So the competition part, the second component, students of university colleges here around North Dakota have had the ability to send in a proposal to our ND Strike program at our rocket.und.edu website for the ability to have about a $500 budget to build their payload and fly a small commercial rocket to learn about high-powered rocketry. And out of the 8 that were selected, 3 will go on to actually Strike's achievement of 25,000 feet with the cluster launch. And finally, we have a final contact down in the Twin Cities, where 1 out of the 3 will be selected and flown to an altitude of over 90,000 feet. So the VLR, the Very Large Rocket, again here last May, we were erecting it here on our trailer, was made and fabricated by about 30 students between UND and NDSU. Almost all the fabrication of the rocket occurred here at the university. Some telemetry was done down in NDSU. The trailer here, designed by our students, mainly by Kyle Anderson and an engineer here, was made out of a U-Haul trailer that we converted with some angle iron and assistance of Rob Tchaikovsky down here in the Whitmer basement. Turned it into, using some winches and angle iron, a trailer that can be broken down and transported about the state for our launches. Here, on the left-hand side, this is in between launches. Direct your attention up here. The brown part will consider the coupler of a rocket. That is to couple together different parts of the actual rocket itself. This is a chamber that gets detonated for, or well, pressurized, I should actually say, for the deployment of the parachutes. For proper fitting, for all types of rocketry, we use masking tape as a good trick. You want to make sure that the two components fit together very nice and snug, so that when the rocket reaches apogee, and it's in the, altimeters aren't 100% accurate, the rocket could begin to tip down before actually deploying the drogue. You don't want the rocket to prematurely separate. So we use masking tape to make sure that the components of the rocket stick together at all times and can only be forced open by the pressurization of the chamber. So over here, this is looking towards the rear of our rocket. This is about a 98mm hole. This fits the N-size motor, as John was talking about classification-wise. So with 1 N motor and then 4 N motors around in a cluster for our final cluster launch is our final configuration. There's some small red switches up here, actually probably really easier over here. These small switches, these switches allow by turning the switches and pulling these 2 safety pyros, these activate and arm the pyros when the switches are turned on. That makes sure that the circuits are fully connected. And we only do such a thing when the rocket is fully erected up on the rail and ready to go. So the trailer, the actual arm of the trailer where the rocket resides can actually tip down for transportation, and it can break apart. All the components here, these arms here are stabilizer arms for the trailer to make sure that it's sitting level. Everything can fit inside the trailer so that we can take it on the highway up to interstate speeds even to transport it around the state. So the altimeters, or our altimeter bay, we put in a small removable chamber here. This board slides out. We have 2 altimeters for redundancy. So if one were to accidentally fail or read the barometric pressure incorrectly, we have a secondary one just in case. This is about a 70-pound rocket right now. 70 pounds falling from 8,000 feet is not a very safe thing. So safety and redundancy works perfect here. ND Stripes had 3 successful launches so far. Our first launch, an 11-foot launch, we achieved an altitude of approximately 2,500 feet on an M-class motor. The secondary launch, again, just a few months ago, actually, in early October, again, 2,500 feet on the M-class motor. We tested here a wireless ignition system that was built down in NDSU and the telemetry system. The telemetry system, which sits up in the nose cone section, houses a real-time data transmitter circuit board that, coupled with our Yagi antenna down at the ground, we get real-time information. Actually, we're supposed to get real-time information. We're still working on getting that to work correctly. And also real-time data, or GPS location. The GPS unit, talking with the satellites, gets downloaded to us, and then once we have the data on our computer, we can upload it to such sites like googlemaps.com, and anyone around on the World Wide Web can see the actual trajectory and location of our rocket launch. So then our third launch, which is this configuration here, we added a camera bay, which is this top section right here. There's a hole for the camera on the other side. And retested the telemetry, and we achieved, using an N motor, which from end to end is about twice the impulse value, 8,000 feet roughly average between our 2 altimeters. So our plans are, in the upcoming months here, hopefully before the end of this semester, is to fly another N-class motor launch in the same configuration, achieving an altitude of 8,000 feet, making sure we have all our procedures done correctly, the telemetry is working properly. But in between then, we'll be working on our fin-can cluster, or cluster fin-can, excuse me, where we'll be launching, hopefully in the summer here, with student payloads to an altitude of 25,000 feet. So here's a photo, again last May, of Pablo De Leon assisting us, team members, actually all of the Frozen Fury team members were a part of this ND Strike team, in coupling together the recovery system. So I'm going to switch over to a video here from our first launch.
Wow.
So this was an M-class motor. So keep in mind, an altitude of approximately 2,500 feet. Our N-class motor that we flew had about a burn time of about 8 seconds, where we achieved then 8,000 feet. So nice clear day, we were able to see all the way to the deployment of the drogue and then the main. And this rocket actually landed less than a quarter of a mile away from our launch trail. It was fantastic. On to the Frozen Fury project. We came together as a UND undergrad team. A competition was, our attention was directed by Dr. Young to a competition called the University Student Launch Initiative, or USLI. It's a competition developed by Marshall Space Flight Center and NASA for college universities to create a proposal that must be accepted. We are one of 11 teams accepted nationwide. There's teams from Wisconsin, the Alabama area, as far as Idaho, and obviously us. So the requirements for the USLI competition are an altitude of 5,200 feet, an exact altitude of 5,200 feet. You must carry a payload on your rocket, a scientific payload, to the altitude. So within a percentage value of that altitude, you are graded. There are other grading criteria as well. Some of the goals and grading criteria for the competition include a working and successful website. Our website is frozenfury.und.